All right, lesson 5. Using matrices to organize data and to solve problems. Okay? Um, this stuff seems really complicated. It's not that complicated. It looks harder than it is because it's a whole different set of how to look at things. But if you understand this, it's going to make your life a lot easier, especially with that graphing calculator in your hand. We're going to be able to take complicated problems and organize them in such a way that with the graphing calculator, we can solve really complex problems relatively quickly. Especially like longer systems of equations, we can solve real quickly, a lot faster than we could with pencil and paper. But a matrix is a rectangular array of numbers. The numbers of rows and columns in a matrix give the dimensions. So we look at things as row by column, R by, oh, sorry, I get a little dyslexic, R by C. Rows, columns. Okay, rows, columns. Okay. All right. And so those are the dimensions. So we'll know where to put things based upon that information. Hey, there he is. Let me hit pause here. Got it. All right. So we've got rows and columns is called an R by C or R by C matrix. Okay, either R times C or R by C. We will look at the matrices shown here in a little bit. As matrix A is a 3 by 2 and matrix B is a 4 by 1. I don't know if I've got those. Yeah, here we go. All right, so here's an example of a matrix. Okay, it's got 3 rows, 2 columns. Okay, 3 rows, 2 columns. Okay, over here I've got a 4 by 1, 4 rows, 1 column. Does this make sense so far? We're not working with anything yet. We just want you to understand how to set up a matrix if they're giving the dimensions, because what's going to be real important later on based upon the dimensions is, can I multiply 2 matrices? Well, there's certain rules for multiplying matrices that involve their dimensions, okay? And if they don't meet these certain rules, then I can't multiply them, okay? So that's a 3 by 2 and a 4 by 1. Okay, each number in the matrix, okay, is an element and has a unique address. Okay, for instance, down here, okay, this is first row, first column, so that would have the address 1, 1. Okay, second row, first column, that has the address 2, 1. Down here, number 3 is third row, first column, that's address 3, 1. So it's going to look like 31. Does that make sense? Okay, but that's how they're going to give you the address. 0. What is the address of 0? 1, 2. Okay, first row, second column. Okay, what about number 2 over here? Anybody tell me what the address there is? 3, 1. Okay, third row, first column. Does that make sense? Okay. But you're going to see it written as 31, so if you don't understand that it's 3, 1 is in row column, it's going to be kind of confusing whenever they give you those addresses. Okay, well, that's how we identify it. So the address of an element is formed by the lowercase letter of the matrix name, followed by the row number, followed by the row number and column number. So in subscripts, therefore, the element located at what we saw on the other page, first row, second column was 0, and at B, third row, first column was the number 2. Okay, matrices can be used to store data that would otherwise be presented in a table, and this can make it easier to perform calculations on the data, such as matrix addition. So let's talk a little bit about matrix addition. Okay, so to add 2 matrices, so if we're trying to add matrix A to matrix B, they have to have the same dimensions. So can we tell me what the dimensions of matrix A are? What are the dimensions?
2 by 2.
It's a 2 by 2. Think about it. It's going to sound like the same way as if you worked at a lumber yard, right? And you're talking about 2 by 4s. All right, this is a 2 by 2. Okay, it's square. Okay, so matrix B is also a 2 by 2, and their solution is a 2 by 2. I know it looks more complicated than that, but I'll make sense here in a second. So to add 2 matrices, where you're adding matrix A to matrix B of the same dimensions, you're going to add each element in the first matrix to the element that's in the same location in the second matrix. So I would add element A, row 1, column 1, to matrix B, row 1, column 1. Okay, so these two things are going to add up, and that's why you see this right here. So I have this, I'm going to add it to this, I'm going to put it here. No, that's not what we're adding. Those are just simply the addresses. Yeah, no, but that position would be 1. The position is 1, 1. Yep. And so, I'm going to add this position to this position and place my solution in that position. Okay? Come down here. I'm going to add this to this and put it here. Okay? Finally, this to this and put it here. Okay? Does that make sense? And not all matrices are going to be 2 by 2s. Okay, we should already know that. So the commutative property holds true for a matrix addition, that we can add A plus B, but it's not going to be any different than if we'd added B plus A. We can put those things in any order because it's just addition. Okay, so a matrix in which every element is 0 is a 0 matrix. A 0 matrix is formed when a matrix is added to its additive inverse matrix. The elements in an additive inverse matrix must be the opposite of every element in the original matrix. Somebody give me a number. 6, okay? So 6, give me another one. It could be negatives. Let's make it a -3. Something else? -2. And finally, 5, okay? Basically what we want, if I'm going to add A to what is equivalent -A, the additive inverse, what am I going to put in position 1, 1? -6. What am I going to put in position 1, 2? 1, 2. Position first row, second column. 3, positive 3. Okay, what about 2, 1? Positive 2. And position 2, 2. -5. Now I'm giving you the addresses, but you guys understand because Eric's the only one who's answering, so I don't know if the rest of you get what I'm actually saying. Are you guys me okay? Okay. So what should be my solution over here? What's going to be all 4 numbers over here? 0. Okay? It's a 0 matrix. So I'm going to get 0, 0, 0, 0. Everything's going to cancel. Angela, you kind of have a look on your face. Does this make sense or does it not make sense? What can I help you out with? Okay, so you're saying, what we're saying is 6 plus -6 is 0. -3 plus 3 is 0. -2 plus 2 is 0. 5 plus -5 is 0. All right, gotcha. All right, matrix subtraction. Same thing, okay? To subtract 2 matrices where we have A minus B, you take the opposite or additive inverse of B and add it to A. Hint, subtract the corresponding element in each matrix and place it in the corresponding element position in your solution matrix. I don't know if I have. I don't. It's fine. So in a matrix equation, okay, we can have matrix equations. An equation might be where we have a variable or that we're putting in a variable instead of a matrix. So an entire matrix can be a variable. We can take matrix A times X, and where X is a matrix itself. To solve a matrix equation, we begin by isolating the variable using inverse operations. We'll look at some examples of that here in a little bit. A scalar is where we take a matrix and multiply every element in the matrix by the same number. Okay? It's basically, it's repeated addition, but that's what multiplication is. So to multiply a matrix by a scalar, you multiply every element of the matrix by that scalar number. Okay, so let's get to some practice. All right, I'm going to address 2 things before I move on. The first is that if we go to our classroom, you should see right underneath the grade log, lesson 1 through 5 flashcards. I went ahead and I did that on Friday. I went through all of your notes and I tried to make flashcards for you so that your first test is going to be lessons 1 through 5. Okay? So you can go ahead and you can be studying now and reviewing now for that test that'll be coming up after lesson 10. Okay, so we're still a little ways off, but after that your tests are going to pick up because they're going to be every 5 lessons. It's just that it takes a little while to get to the point where we need to for the first test. Okay? So you can go ahead and open up that. You can go ahead and be studying that in your free time. We'll do some of that on review day. The other thing that I'm going to start doing for every class, so don't think that I'm picking on you, but as part of every homework assignment, the last question I want you to add to every homework assignment is this question is, this is how this would be used in everyday life. Or it doesn't have to be your everyday life, but how somebody in some profession might actually use this. Okay, because what do you think the most commonly asked question that I get is? When will this ever be used? That's the question I want you to answer. Okay, I want 2 sentences minimum. How will this ever be used? Okay, this is how this is used. You can get on Google, research. How are matrices used in life? Does that make sense? Okay, I want you to be able to walk away from each lesson saying, okay, well, yeah, I never even thought that that's how, I didn't even know that people use this, right? And I YouTubed it or I Googled it, and this is how it's used. Okay, so that's the question. You can go ahead, I would write it down wherever I'm doing my homework. I need to answer this question. The question is, how will this ever be used? Does that make sense? Okay, so getting back to our stuff, this is one of the last things that you saw being addressed. Let's get to where I want to be. Okay, and this is a matrix equation. Essentially what we are saying here is that I have this blank plus, -4, 3, 10, -1, and it equals this matrix right here. So the answer to y is in 4 parts, okay? What plus -4 equals -16? -12. -12 plus -4 equals -16. What plus 3 equals 8? 5. Okay? What plus 10 equals 14? 4. What plus -1 equals 10? 11. So your answer for what is y is it's -12, 5, 4, 11. That's what you get right there. That's an example of a matrix equation. Does that make sense? Okay. All right, let's clean this up a little bit here. All right, we've got question number 2. Okay, this is matrix subtraction. So the important thing to remember is that this is a subtraction sign right here, right? So I have to read each of these just like it's 4 separate equations. Okay? So -2 minus -6. Okay? Do you understand why it's 4? Well, Eric understands because he read off the answer. Do you guys understand why it's 4? -2 minus -6. What's happening there with those double negatives? Becomes positive, so it's basically the equivalent to 6 minus 2. 6 minus 2 is 4. Okay, I've got 2 answers that have that. Let's come over. 6 minus -9. 15. All right, so now we would kind of know what our answer is, but 9 minus -6, that's 9 plus 6 is 15, and -2 plus 7, 5. Right, so do we understand how all that works? So we've done some matrix subtraction here. Okay, now they also told us in here that matrices will represent data that normally would have been in a table. Okay, here's an example of that. I've got store A, I've got store B. I've got small, medium, and large sweatshirts. Okay, which one of these matrices represents the data that is there? B, because it has it has the correct dimensions, right? How many rows does my table have? How many columns? All right, so that would either bring me to either B or D, correct? And then we're not really changing the order of the numbers. It should be 10, 24, 15 on the top row, 22, 34, 25 on the bottom row. That we're not alternating anything. We're not flipping anything around. Okay? All right. Let's see. You guys are normally out of here at what? 36. So what I'm going to do at this point, because it's 10:26 right now, is I'm going to stop on the video. I'm going to let you guys work on homework, and I'm going to answer as many of your questions from that as you need.